Hello, good morning, good afternoon, good evening, wherever you might be. My name is Sean, and I'm delighted you're joining us for today's ESPC community webinar. Today I'm joined by Nagar Shabazz, who will cover Azure AI in action, real-life challenges solved using Azure AI services. We love hearing you guys have to say, so remember to join on the conversation about today's webinar and more on X. Our handle is @ESPC_community and our hashtag is #ESPC25. Tweet us, tag us, and tell us what you learned. Don't forget to check out our Learning Hub, which is updated with the latest blogs, ebooks, webinars, and how-to videos. You can access and view the Learning Hub by visiting our website, sharepointyacht.com, and clicking the Content tab at the top. Don't let the learning stop here. Continue to keep up and stay ahead by joining us for our next webinar, How Azure Functions on ACA is Good for AI Development, with Jonah Anderson, MVP. This webinar will take place tomorrow, Wednesday, 28th of August, 11 a.m., 12 p.m. CEST. For more information on this webinar, please check out www.sharepointeurope.com/Azure AI Week. At ESPC 25, we're going all in on AI, with expert-led sessions covering Azure AI Foundry, AI agents, responsible AI, generative AI, Copilot, OpenAI, and AI in SharePoint. This is your chance to learn directly from the top experts and Microsoft MVPs, driving the future of AI and productivity. Scan the QR code on screen and use the code Azure AI Week 200 to receive €200 off your ESPC 25 ticket. After the webinar, we'll have a questions and answer session. Type any questions you might have in the questions box. Questions will be selected and answered at the end of the presentation. This webinar will be recorded and added to the Resource Center, where you'll be notified by email when it is available. And now I'm going to pass you over to today's webinar presenter, Nagar. Thanks for joining us today.
Thank you, Sean. Let me see if I can pick up the screen.
Yeah, I can see your screen.
Perfect. So we get into presentation mode.
Yeah, that's perfect.
Thank you. Let's get started. Hello, everyone. My name is Nagar Shabazz. I work as Microsoft Cloud Solution Architect at Capgemini in Sweden. And it's a pleasure to be here. Today, we are going to take a look at the existing Azure AI services. We're going to look at the cost factor behind some of these Azure AI services, and also we will have a comparison of the AI services with OCR support. As you know, we already have a whole range of Azure AI services available. Some former cognitive services got retired, and more advanced versions of Azure AI services have been available in Azure AI Foundry. Azure AI Foundry is the unified Azure platform for trying out different Azure AI services. You can explore Azure AI Foundry and build and test and deploy your apps, whether you want to build a POC, proof of concept, or a fully fledged production application. You also have the possibility to upscale and scale up your POCs to production level applications once you're done with them, and you will have the confidence that your apps are hosted on Azure and they are grounded in responsible AI practices. Out of all these different Azure AI services that I have listed on the screen, we're going to specifically focus on Azure AI Search Service. As you see, it comes in different flavors. We're going to tap into Document Intelligence Service as well as Custom Vision Service. And now we have the pricing factor. I guess there's a lot of interest in knowing how the pricing works around Microsoft Azure AI services. Many of these services have a free tier, So if you want to use the free tier, you can use F0 as your SKU for your Azure AI resource, and you can explore these services. Of course, there are some rules of thumb when it comes to pricing of different tiers. The pricing is mostly based on the number of transactions that you send per second, known as TPS. And of course, there are some service features that are available in specific tiers, and that would impact the cost. And of course, there's a predefined number of transactions that is included in the costing or standard costing of the tiers, which means that if you exceed the limit that is predefined, you might receive extra charges. Now let's take a look at Azure AI Search Service. Architecturally, the Azure AI Search Service sits between an application, which could be a Gen AI app, it could be a conversational AI bot, or it could be any other application that requires, let's say, AI-enriched responses. And on the other end, the Azure AI Search Service instance has the unindexed data. Inside your organization, your data could be hosted on Azure Cloud or other public clouds. It could be hosted on premises. However, it is unindexed originally. So the first step of the way is to get your unindexed data indexed by the indexing engine of the Azure AI Search. And of course, if your data is hosted on Azure, you can use some AI-enriched indexing to add more edge to your index data. For example, you can index images, or you can use LLMs, for example, when handling the indexing stage. After the data is indexed, then the queries are, of course, sent to the index data, and the responses are retrieved and returned to the conversational bot or your front-end application that is generating the queries and waiting for the responses. The kind of use cases that we have for AI search service is quite broad. Basically, any enterprise search scenario would fit in well, specifically search or let's say conversational search scenarios where you would like your user experience to have a more interactive, AI-enriched conversational experience when they are looking for information. I mean, these kinds of scenarios are good examples as use cases for Azure AI Search Service. And as a developer, there are some developer tools. There are a lot of examples online already that you can use. You can basically utilize or consume Azure AI Search Service using its REST APIs or by using the Azure SDK that is available for you. And there are also some sample solution accelerators created already by Microsoft and provided. For example, for the common scenarios like chatting with your data, if you want to build a chatbot, or if you would like to have a conversational deep search scenarios, knowledge mining solutions, you can always refer to the accelerators that are already provided by Microsoft. As I mentioned earlier, Azure AI Search Service comes with different, let's say, flavors. One of these approaches, search approaches or flavors of search is the vector search, which basically supports indexing and querying of content with numerical vector embedding. So on the indexing side, you have your content that needs to be indexed, of course, and through the indexation, some vector representation of your data is generated. On the query side, when the end user's query is provided, we also have some numerical vector embedding generation on the query. And the Azure AI search engine will utilize the vector embeddings of the query and pass on the query looking for the closest neighbors in the search index vector representations of the data, picks up the closest neighbors, and of course there is some ranking applied before the data is returned to your application. If we want to look at possible use cases for these scenarios, have you lost my screen? Sorry for the interruption, but it feels like I left presentation mode.
Yeah, it's gone out of presentation mode for a sec there.
All right, so let's see if I can start it again.
Perfect.
But you have my screen, right?
Yeah, I can see the presentation, yeah.
Perfect. Cool. So we were talking about use cases for vector search. Usually when you would care about getting very similar search results, you would like to have a close proximity in response when you search for a certain query or search phrase. You can refer to similarity search results coming from vector search. There are two different types of search that support vector search: hybrid search and multimodal, which we will get to shortly. And of course, in multilingual scenarios, you can use the Azure AI vector search. This type of search is available in all the regions and all the tiers. So it's been around actually for a while, since 2023, I believe. The next flavor of Azure AI Search Service is the full text search, which basically rides on matching the plain text coming from the query with the index data. And what it does is that it utilizes some additional parsing, analyzing, and querying components within the search service to break down the search queries that have been sent in. Basically, there is some query parsing taking place, removing the operators, basically pulling out those key words in the query and reducing the size of it. And then, of course, there is some lexical analysis applied to the queries before the search engine actually scans the index data to find a match for the search query that has already been cleaned up by the parser and analyzer components. Once the data has been, once a match has been found in the search index, of course, there is some scoring that takes place under the hood. So there is some ranking applied to the search results, and they are actually sorted based on the order of relevance and eventually returned to the agent application that was initiating the search in the first place. So the power behind this type of search is, of course, the fact that it finds exact matches for the keywords that you have searched for. And of course, the results that you get are ranked, so it increases the level of relevance when it comes to the responses that you receive. Another type of search is the hybrid search, where we are dealing with one single query request. And the reason why it is called hybrid is because it supports both of the variations we just talked about, meaning both full text search and vector search are supported with hybrid search. And there is also a semantic ranker in the play to combine the search results from both full text and vector search queries and generate the final result, return it with the highest relevance possible. Of course, the fact that hybrid search supports both types of search types makes it a very powerful scenario, as the vector search will be looking for conceptual similarities. However, the keyword search is looking for the exact text values. For example, if you're looking for product codes or specific people names, those scenarios can be covered by hybrid search. Besides the hybrid search scenario, we have one more type of Azure AI search approach, which is known as the multimodal search. Multimodal is referring to the fact that this type of search can support different types of content types when it comes to indexing. So it has the capability to ingest, understand, and retrieve information across different types of content types, such as texts, images, audio, and video content type. So it's not just bound or limited to text search queries, which is, of course, quite powerful. It enables the end user to, for example, ask for some process flow to be described in text by only providing an image or diagram of the process. So multimodal search types are quite powerful when it comes to analyzing images, diagrams, graphs that do not come with text necessarily, and you can get some description of what is going on inside the image fully written in the response. Of course, the traditional search is, of course, supported by multimodal. You can still do your text search. You can count on vector search, but of course, the fact that it's powerful enough to handle images, videos, and audios is a big differentiator for this type of search. Let's see. Talking of multimodal LLMs that are actually used for multimodal search as well, we have a couple of samples on the screen right now. As you see, the GPT series are all multimodal LLMs. We also have additional Microsoft and Meta owned multimodal LLMs as well. Specifically, when it comes to GPT series, GPT-5 is one LLM model that was recently announced, as you know, and it is known as a more efficient and more powerful model when it comes to handling more complex problems and basically deeper reasoning model that is behind GPT-5. And it comes then different flavors, different variations. You have GPT 5.0, which is designed for more, multi-step, complex, logic-heavy queries. Whereas you have GPT 5 mini, which is a lighter version of GPT-5. And if you are cost conscious building your applications, GPT-5 mini would be a good option. And you have also the nano version and the chat versions of GPT-5. The nano version is optimized specifically for speed and lower latency. And the chat version is, of course, a multimodal, context-aware model for conversations, the conversational bots. These models are all available to be explored on Azure Portal, Azure AI Foundry if you have Azure credits, or if you would like to use GitHub Codespace, you can explore these models and try them out. There is one more type of search, Azure AI search, that I would like to tap into. It's currently in public preview, and it is the Azure AI agentic search. This Azure AI agentic search is also a very powerful addition to this range of Azure AI search services. And it basically generates a multi-query pipeline per every request that comes in. So on the one side, you have the query planning part, and on the other side, you have the performance of the query, retrieval of the results, getting the results ranked, and then, of course, returning the results as one unified response. The way it works is that on the agentic side, the queries that come in are actually broken down into subqueries. So if there is a search prompt that is complex, it has a lot of ifs and conditions, then the agentic layer breaks down the prompt that has come in as a search query to multiple subqueries. And then the knowledge agent, which is the search engine on the query side, runs these subqueries individually in parallel, basically looking for the best hits or best results to be retrieved and returned from the search index. On the search index side, we support structured data and unstructured data, text, and vectorized indexes as well. So once we receive responses per every one of these subqueries, then there is another component that steps into the picture, and that's the semantic ranker, which applies 2 levels of ranking to make sure that you get the highest, most relevant response per every one of those queries. And then, of course, in the end, all these finalized responses per subqueries are merged into one unified response and returned to the application via the LLM layer in a user-friendly conversational way. Of course, this whole procedure is a bit performance heavy. This can be this can cause some latency considering all the steps that take place behind the scenes. However, the results that you get have high accuracy, and also the fact that it can handle complex requests makes it outstanding. So if you look at the use cases and what would fit the usage scenarios of agentic search Azure AI service, it would be the complex scenarios where you would like to receive prompts that are quite complex through, let's say, a RAG application or chatbot. And of course, getting an accurate and highly relevant response matters. As I mentioned, it supports the traditional search approaches like the keyword matching, as well as the semantic vectorized matching when retrieving the responses. When it comes to development stack, in real world, basically your application will be triggering the pipeline of all these subqueries being generated, sent to the backend search engine and all that. The trigger will come from your application. And at the moment, it seems like only GPT-4o and GPT-4.1 LLMs are supported for agentic query planning. And GPT-5 is not available yet. Looking at the pricing for Azure AI agentic search, there are two dimensions when it comes to pricing. There is billing for the query planning part, and there is billing for the semantic ranking side after the results are retrieved. For the query planning part, obviously, Azure OpenAI with GPT-4o and 4.1 models are available to be used in a pay-as-you-go billing model. It is token-based, so it is not query-based. You pay per token, per number of input tokens and output tokens when it comes to the query planning layer. And if you look at the table that I have on the right-hand side, you can see the classic single query pipeline versus the agentic version. In the classic version, the cost was query-based. However, in the agentic version, we are dealing with token-based billing model. So that is for the query planning side, pay as you go. For the query execution side, we have several aspects. We have the semantic ranking side that is a premium feature, and it comes with its own costs. And of course, the Azure AI search engine, the indexing component of it, which is following the pay-as-you-go model. And again, you are charged based on the number of tokens that you send as input to the semantic ranking models, and also the number of tokens returned by each of the subqueries that have been running in parallel. Okay, so we talked about the comparison of the classic single query pipeline versus the agentic search that is already highlighted. On this screen, which is actually a Microsoft slide, we have a list of some common use cases for generative AI application scenarios. As you see, the business problems are listed at the top. Obviously, the rationale behind using more and more of AI is to increase productivity, to enable more and more of automation, and to increase the level of customer experience when it comes to, having a more human-friendly experience rather than a more robotic computer-based interaction. In all of these lanes, we have different solutions that have the potential to be rethought and revamped and rebuilt using Gen AI services. Of course, the most common scenario nowadays is the conversational bots and agents. However, agentification is not just limited to running search queries, asking questions and getting responses in a search mechanism. There are other opportunities when it comes to agentifying, customer service, when it comes to agentifying and automating reporting, forecasting initiatives, creating a virtual assistant for your daily activities, and so on. So if you would like to get started today to build your generative AI assistants, you have different platforms or different choices to choose from. Of course, you have the Microsoft 365 Copilot that everyone is familiar with. And you can, of course, build your own custom copilots or agents using the low-code platform of Copilot Studio, which is highly recommended when you're dealing with processes and you need to automate, basically either using Power Platform or a more professional development platform as well. So both low-code and pro-code platforms are available out there. Based on the organizational strategy, you can make the right choice of the platform and basically identify those low-hanging fruit opportunities for automation and agentification. Of course, if you're a professional developer, you have the Azure AI Foundry, which comes with Azure Bot Framework, and loads of examples that are available online that you can refer to and build your solutions. The last point that I would like to highlight is the matter of OCR. OCR stands for Optical Character Recognition. Basically, many of the Azure AI services offer OCR capabilities, and you might be stuck in this dilemma of which service should I use if I have a demand to be able to handle OCR or optical character recognition. So we have the Azure AI Custom Vision service, which covers OCR functionality on a basic level when it comes to images and videos. And it does not support natural language. So it's basically an API endpoint that you feed an image to and you get, some text extraction back. So there is no RAG add-on or human language touch to it, no LLM involved. We also have the document intelligence service, which has more advanced OCR functionality. And in this scenario, you can provide, PDF files, for example, or the receipts from different accounts, The data could be in structured format or unstructured format, could be tabular representation of data inside a PDF, or it could be unstructured data as it appears on a receipt, text line by line. Regardless, Azure AI Document Intelligence can handle OCR and text extraction to a good and advanced level. However, just like the Custom AI Vision service, there is no natural language support here either. So you're dealing with an API endpoint. Of course, there is a Document Intelligence Studio, I believe, same for the Vision Studio, where you can, explore and try different endpoints and different options. However, when you're building your application, you're dealing with some API communication pattern. And then, of course, we have the GPT series, where you get the option of basically feeding in text and images as your content. And both GPT-4 and 5 can extract OCR, can extract the text from your provided image or provided text in an advanced level. And not only OCR is supported, but also LLM touch is present here. So you can actually get a human language response in this case. Of course, you can communicate with these APIs, OpenAI services via APIs as well. However, you can also count on getting natural language responses, not just a JSON object as a response. But the response will be human friendly. And when it comes to comparison between these options, it's important to consider all these different parameters and factors. And of course, the cost element is something that should be highlighted as well, that usually the OpenAI series, especially the mini versions, are more budget friendly, and you basically get more value for the money if you go with the OpenAI services with GPT 4 or 5 LLMs to handle your OCR use case scenario. This is something that we have learned during client delivery hands-on. Let's see. And with that said, I would like to wrap up. Thank you all for joining the webinar, and we can open the floor for some questions if there are any.
Yeah, perfect. Thank you, Nagar, for a great presentation. So we'll now get into the questions and answers part. Should you wish to ask a question, please feel free to type in the questions box now. So our first kind of question was, not interested in a charge approach, as we find there are standard approaches to those mapped into AI. We find the close neighbor feature introduces deviation from AI answers. Perhaps those should be listed separately in answers below. Next step, poorest response come from image matching, where subsequent requests for need better result does not work. AI gets locked into images too strongly. For example, searching for plant types.
Mm-hmm. Is there a way where I can read the questions also? It's
I'll put it in the chat. I'll send it to you in the chat.
yes, that would be great.
Yeah.
Let's see if I can find the chat window down there. Yes. Okay.
You should be able to see there.
Yeah, I see
That's the
your
first
post.
part of it. Yeah.
Let's see. I just see your post where you have mentioned if they have any questions.
Oh,
All
perfect.
right.
Oh,
Okay, there is another one. Hang on,
yeah.
let me just take a look at it. We find the close neighbor feature introduces deviation from AI answers. Perhaps those should be listed separately in answers below. Next step. So is the second post a continuation
Yeah,
of this?
they're all the same person. Yeah, the three of them.
Yeah, cool. Let me see. Poorest response come from image matching, where subsequent requests for needs better result does not work. AI gets locked into images too strongly, for example, searching for plant types. Okay, which service have you been using? Is it the vector search that you're referring to when you say neighboring feature, close neighbor feature, or have you used another flavor of search? Can you clarify what type of search you have used?
Yeah, I'll message
Yeah.
you when he responds back. So you said Copilot?
Copilot
Yeah.
is using, I think, GPT behind the scenes. Okay, so that is your experience that when you searched for images, or actually, I guess, content on the images, it got caught up, huh? In my experience, I've had images like diagrams embedded inside a PDF document. And it wasn't a very advanced diagram, but it was a pie chart. And the search results basically came out very descriptive of the different portions of data that had been allocated in different segments of the chart. Also, tabular data inside PDF has worked fine for me, but depending on what type of image you've uploaded, yeah, it is still early stages. Maybe we need better tuning on the models. Also on the indexing side, there are tuning configurations that could be done to refine the answers. Yeah, so Copilot in itself, I mean, there is a public Copilot service and there is a business private one. It's not really the same story as using Azure AI Search Services in a custom application. So there is room for more exploration there, I would say, in your experience for the cases, the images that you uploaded. And nothing is perfect. We cannot say everything is perfect and working fine, but in my experience, diagrams and tabular screenshots have worked fine. I'll be happy to take this discussion further. Maybe we can take a look at your experience offline. You can contact me. You have my contact on the screen, and I'll be happy to look into the scenarios that you have experienced and verified.
Perfect. So this next question is, how is content understanding surface different from document intelligence?
That's a good question. Content can refer to different types of content type. So content can be in video format or in image format, whereas document intelligence is a specialized service for handling documents, loads or large volumes of text. You also have higher capacity if you use document intelligence service if you're dealing with larger volumes of text that need to be processed. But the other service is more generic. It's not bound to only text. it's also other types of content types, such as videos and audio, images, and so on.
Perfect. And the next question there is, the webinar is quite insightful, but what are some of the deviation we may encounter while using Azure AI?
It depends on what you mean by deviation. As I mentioned in the beginning, of course, there has been good care put in place when it comes to usage of responsible AI. So there are policies, there are content trimmings that are in accordance to responsible AI. So if that is what you mean by deviation, I think using Azure services can give you the confidence that you are compliant to responsible AI, unless you meant something else by deviation.
Perfect. The next question there is, what KPIs or success metrics do Microsoft and partners recommend to justify the investment in AI services?
Success metric, that's actually a very good and interesting question. If I'm still sharing screen, I would like to go back
Yeah,
to
share
one
screen.
of the slides. Your success measure should be verified based on the amount of automation that you have introduced. And what you can do is to start measuring the amount of time and cost that you're saving by introducing automation and agentification into your organization. If you manage to capture these measurements when it comes to how many number of hours of work have we saved to be spent on new initiatives rather than on ongoing repetitive tasks, in numbers, and also as a result of that, how much money has been saved for the company or the enterprise that you belong to. These are good measurement values, both cost and time measures, to highlight how much revenue you have basically saved for your organization. Usually, there should be an innovation center in every company or organization. You need to create an innovation backlog where you can capture ideas. So you involve and engage all the employees to come up with their ideas regarding, how they could do their jobs more efficiently. And then these ideas could be reviewed in the backlog, and they could be prioritized. And you can start by, automating one or two highly prioritized, scenarios, and then keep it under the magnifier, measure the amount of time saved, and as a result of that, maybe some consultants are not needed anymore. Maybe the attention of employees can be spent somewhere else. It's all about numbers around time and cost. I hope it answers your question.
Perfect. The next question there is, beyond the API usage, what are the hidden cost factors, example, storage, retraining cycles organizations should prepare for?
The major part of the cost comes from the indexing part of the search engine. Sorry, apologies. So the index part can be heavy. So it's important to clean up your data, and before you have the search index running and indexing your content, your organizational content, clean up the data so you don't need to pay for outdated data that is not relevant anymore, but they get indexed anyways. So data cleanup is one step that you can do when it comes to search. Sorry. This way you can save costs, of course. The models that you use, let's say for OCR purpose, for example, makes a difference. Different models and AI services have different pricing mechanisms, and some of them are token-based, some of them are query-based, and some of them are multimodal. So at times, multimodal services can be very efficient, both cost-wise and also when it comes to the value that they provide. The example that we had regarding OCR was supposed to actually illustrate the same scenario as a sample scenario. You can use image custom vision service, or the document intelligence service for the same purpose, as well as the GPT models. But cost-wise, GPT gives you more and ends up being more budget-friendly as it has a mini version. So you need to do good research before you decide on which Azure AI service would fit the purpose for your particular scenario best.
Perfect. So next question there is, are there methods to convert data from web into a standard format to save time?
There are, beside Azure services, for example, the search index that will basically index your data in whatever format that you have, image, text, and then you can query the data. You also have low-code platforms which can enable intelligent agentification without the need to necessarily use Azure services. You can use the local platforms like Power Platform. There is AI Builder component or add-on in Power Platform that basically enables extraction of text, for example, from images with minimal development effort and without the hassle of understanding which Azure AI service would work best. In that scenario, for example, if you opt to go with AI Builder, you need to pay for licenses, obviously, but then you don't have the headache of picking and choosing which Azure AI service would technically work best for your scenario. You just get the job done as soon as possible by using the local platform. Of course, there are different services for different use cases. If you are a developer, if you're an architect, you would probably prefer diving into the Azure territory and exploring with different AI services. However, if you come from the business side and you are more result-driven, you would like to get things done as soon as possible, then the local platforms would be an option to look at.
Perfect. I think that's all the questions. So on behalf of the ESPC community, we'd like to extend a big thank you to you again, Nagar, for taking the time out today to carry this webinar. Really appreciate it.
Thank you very much for having me, and thank you everyone who joined us and stayed with us.
It was a great webinar. So that's the end of today's webinar. You can find this webinar and more at sharepointeurope.com/resource center. Thanks again for all of you joining us today, and I hope you join us again soon. Take care.
Thank you. Bye-bye.